So once again, this is the multiplication rule. The AND is used here. Are these two things independent of each other? Well, let's calculate. Okay, so from a product perspective, let's calculate the probability that either way, depends on which way do we want to do this. This is the same. This should be the same as the probability of a 3 customer and they're on a go plan. Okay, so we know already that they're dependent on each other. Okay, maybe I'll check that. Okay, so one way to check it would be to have a look at the probability that they're go, and then to have a look at the probability that they're 3, given that they're go. Okay, we could test that. Actually, am I doing that the right way around? Okay, so let me just think here. So it's, what did I say earlier on? The probability that their x, y has to be equal to the probability that their x. So actually, what I really need to check here is I need to compare the probability that they're go to the probability that they're go, given that they're a 3 customer. That's the right way to do that. Okay. So the probability that they're go, well, how many go customers? We've already done that. 65 chances out of 100. So this becomes 65 chances out of 100, and the probability that go, given that they're 3, so they're 3 customers, so they're along here, the probability that they're go, there's 35 chances out of 60, so we have 35 chances out of 60. Now if we just reduce them down, we could divide by 5. 65 divided by 100 is going to give us a value of 13 over 20, and well, the question is whether they're equal. 35 divided by 60 is going to give us a value of 7 over 12, yeah, in a reduced form. And you can see that they're not equal. So hence they're dependent on each other. They're dependent. Okay. So now we can calculate this probability. Let me just move this over here. So the probability that they're go and 3, well, let's have a look at that. Okay. The probability that they're go customer and their 3 customer is equal to the probability that they're a go customer times the probability that they're a 3 customer, knowing that they're a go customer. Yeah, if you want to do it that way, or you could look at the probability that they're a 3 customer and a go customer is the same, that their probability that they're a 3 customer times the probability that they're a go customer, knowing that they're a 3 customer. So these things are exactly the same. Yeah. The point being that if they're independent, this just calculates down to be the probability of t. If they're independent here, this bit here calculates to the probability of g. But we know that that's not the case. They're not the case. They're not equal to each other there. Okay. So which way do we want to do it? Well, the probability that they're a 3 customer. Let's do the second one here. The probability that they're a 3 customer, there's 60 chances out of 100. Okay? The probability that they're a go customer, knowing they're 3. So we know they're 3. What's the chances? So here they are here. What's the chances that they're a go customer? You have 35 out of 60. So you have 35 chances out of 60. And you can see the denominator and the numerator here cancel, which gives us 35 chances out of 100, which is 7 chances out of 20. Okay? Yeah, 7 chances out of 20. What about this one here? So this probability here was this one here calculated. Okay, this one here is, well, the probability that they're a go customer. Okay, the probability that they're a go customer is 65 chances out of 100. Okay, times where's that gone to? Times the probability. Move that out of the way. Times the probability that they're a 3 customer, knowing that they're go. So times the probability that they're a 3 customer, knowing that we know that they're go. The chances that they're 3 is 35 out of 100. So that's times 35 out of 100. Okay, which gives us, you can actually, that gives us the probability that they're a 3 customer, knowing that they're a go customer. So a 3 customer. So we know they're a go customer, so they're down here. The chances that they're 3 is 35 out of 65. So that should be 65 here, which now gives us 35 chances out of 100, which is, yep, 7 out of 20. So you can actually see here, note, okay, that doesn't matter which way we do it. The probability that they're G and T is the same as the probability that they're T and G. Okay, so there's no difference between them, because this is 7 out of 20 and this is also 7 out of 20 here. Okay. So guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this video, another video in our series of videos dealing with probability theory and using contingency tables as a way to express or to understand our probability rules, I hope that this video on the multiplication rule, I hope that was in some way intuitive, and more importantly, I do hope that was helpful for you. And thanks for watching. Okay, bye bye.